Boom, boom. Boom, boom.
Welcome to the Ask Me Anything live from Perf Bytes. So, first of all, hi, Mark. How are you?
Second of all, hi, Henrik. It's great to see you, brother.
It's been a while.
Yeah.
It's been a while. I think
It has.
when did we do the last Ask Me Anything? I don't remember. I don't
It's
recall.
interesting that you ask that because it's a great opportunity to tell people to go to the Perf Bytes YouTube channel, which they might be watching us on YouTube right now. But like Twitch is ephemeral. So you do your Twitch and then Twitch disappears. So you can hit for the long lasting YouTube content, YouTube, Facebook. I think LinkedIn even disappears after a while.
I think it depends on the number of comments and depends on how active the content
Discussion
is.
is.
Yeah. Otherwise, it disappears after a while, for sure.
Yeah. So go to the YouTube channel and there's all of the stuff that we've done for Ask Us Anythings, interviews that we've done with different people. So on the Friday show that I do every other week or so, I had SpeedScale, the guys, they were the ITKO guys that were at ITKO, Lisa Virtualize and CA and all of that. So that was a fantastic conversation. And then our friend, was it Roger? Yeah, Roger from Abstracta. Now he's making the rounds. Abstracta's gone. Colantonia's had him on, so it's good. I'm really glad we made the shift to YouTube, and I'm hoping that the viewing audience is equally pleased with us moving to YouTube. Exactly. Speaking of which, I'm going to tweet out the fact that
we are live.
We're live. Here I go.
We should definitely promote that for sure.
Here I go. I'm going to send that out.
While you're doing this, I'm just going to remind how it works. I mean, no surprises. We are going to spend 1 hour together, and we're going to cover a few topics. And of course, if you have your questions, if you have anything in mind that you want us to discuss today, don't hesitate to drop your questions into the chat, and we will try to answer to your questions. So bring on your questions, and we will answer that.
Yes.
So welcome everyone, and it's been a while, and in fact, I hope that everyone had a pleasant summer. I did, at least. It was pretty hot over here where I live, and where I went. So, but yeah. I started to.
There was also super hot and also more flooding, right? Like you had some flash floods.
So much in where we're in Europe. I mean, at least where we had very high, very big, very hot temperatures, and no rain at all. So it's very.
So more of a drought. So everything went to Pakistan, which is devastating, actually. Like Pakistan's major stuff is flooded out. Yeah, that's really sad.
Yeah, and then I'm pretty sure that rain will come, and it's going to be very heavy rain like usual.
Yeah.
That's what we're facing. What about you, in fact, Mark?
There's been a drought. There's been still the tail end of a pandemic. They're like older people in my family finally got infected with COVID. And so they took whatever the drug is. So that's still, there's this virus thing that's still happening. That's awful. Our ex-president is getting, taken to the cleaners in a legal sense, potentially. So that's always fun. The Queen died, but then, we kind of left the UK behind as Americans, I don't know, 200 some years ago or more. So, yeah.
So, by the way, I will be tomorrow. I will be in the UK. I will be in London. So, if anyone,
is there a meetup? Or what are you doing?
No, it's a conference. So it's SRE Days in London. So there is plenty of interesting speakers covering, of course, observability and SRE topics. So if you want to join us as a last minute, check it out on sredays.com, and you will have all the details of that conference.
Is it SRE Day?
Yeah.
Yeah. sreday.com.
Yep. Correct.
But it should be .co.uk because it's in the UK. But it's not always in the UK.
Here it's in the UK. So,
exactly.
So it's going to be my... it's been a while that I've been in the UK, so it's going to be interesting. First time after the Brexit.
Yeah.
So we'll see. We'll see what happens.
Yeah. Also, people can chat us.
Yep.
This is live. It's happening right now. It's real time. So you can ask us anything about barbecue. Hey, have you had anything on the smoker
I had
this
I had
summer?
briskets. I had some pulled pork, and I did also some a lot of different flavors of
Yeah.
beef. But the
Do you know?
brisket, I had a briskets with no fat because I changed butcher, and the guy presented the meat, and he basically removed everything was super dry. And I looked at it and say, "Hey, how do you want me to cook this?" And then I tried it, but it was good.
Yeah.
But I had to make a trick to make it a bit more juicy. But
Yeah. We have some private chat groups, about smoking meats, and Philip Derop, who is from Belgium, has one of the smokers that he got sent from somewhere. He sent it overseas, brought it in. So he has a Weber Smoky Mountain thing in his yard in Italy. And he had mentioned that you have to do like the cuts of meat that I'm used to. You get slightly different cuts of meat if you're in Asia, if you're in France, if you're in Belgium, you're in different places. So a brisket, the way you get a cut of meat in France, might be different than the cut of meat that we would. So when you say brisket, is it pretty similar? Or are there some cuts that are like, I don't even know?
they don't even know what it is, so you have to explain. So because it's not a something that the French people eat.
Yeah, yeah.
It's a part of the animal that needs to be slow cooked. So usually it's like you put a lot of juice, a lot of sauce, and you put it in a big pan and you cook it during hours.
Yeah.
But the way of doing it in the barbecue, they don't know that approach. So for them, it's not. So when I ask, "Hey, it's a brisket," so they say, what?" And then I explain,
What?
there is two muscles, blah blah blah. And but then I always so far I was successful. So
Yeah.
but I'm pretty sure it would be interesting to buy a real one from a butcher that knows exactly how to cut it. But that will be interesting to see, to be honest.
Yeah. Exactly. Very cool. All right.
All right.
I'm tweeting and chatting things out more.
So before we wait for any questions coming in from our community, we can maybe start with covering a topic. And
Yeah.
I heard that you moved to Kubernetes.
Yeah. Well, it's a commensurate of a bunch of things. So we had been for years a New Relic shop, and we tried some Datadog, and there's some 24/7, and there's just the Azure Insights and things. And so starting in March, we at my company and my team, I'm kind of spearheading the Dynatrace rollout. And of course, we looked at all of the ecosystem of tools that integrate. Of course, you have this K6 extension that works for Dynatrace, so we can move metrics into Prometheus, Dynatrace, Influx, wherever we would go. So there's a little bit of Grafana, Influx. Mostly we're a SQL.NET SQL kind of shop, and Azure. But now you get bigger and you start expanding your engineering, you're going to end up running stuff. You're in Nginx, you're going to start running K6. And of course, all the references for K6 are, well, you're going to run this in a container on top of a Kubernetes cluster and then set up your replicas and away you go. And it's like, all right, and then my colleague Cliff was working on machine learning. So he's got some AI stuff for models for anomaly detection or infrastructure anomaly detection for security. Well, all of his stuff, like to use a GPU to crunch models, all of the drivers were horrible trying to work through a Windows kernel, through this and hypervisor and all this kind of crap. But he's like, let's just get the cheap ESX VMware and give me a native driver so I could talk to these GPUs. So we have 4 machines in our liquid cooled super load generator world that are all running ESX. And of course, all of Cliff's work for scalable model building was all running on top of Kubernetes. So we terraformed a cluster and we've just built, I think it's a collection of like 9s, like 3 control machines and 6 worker nodes set across 4 different machines, some for AI machine learning, some for performance. So we have a perf lab. It's been great. I had given all this advice for years, worked with people who were deploying JMeter on Kubernetes, deploying their apps on Kubernetes, deploying Dynatrace underneath Kubernetes and container. I'd never actually built one myself. So now I'm actually doing it. It's pretty cool. It's pretty awesome. And there's a lot of things to know.
Yeah, and
Yeah.
and what about the load test so far? How was it? So, using generating
It's
load from a cluster, utilizing the internal network of Kubernetes. I mean, what's your experience so
So
far?
there's so one of the things that we're doing, because we're a PCI shop for financial transactions. So even if you're in the tier 2 non-sensitive environments or non-confidential environment, we're still really conscious about any tech that gets pushed anywhere. So we run Calico. Calico is like a network layer, or it's sort of a firewall within the cluster, an intra-cluster firewall, which runs on top of that. And then we run Red Hat, so we'll probably run Creo, or I guess the newer other one is Podman now. So I have our pipeline for performance, everything's been written in JMeter and runs natively in a VM, Linux, Red Hat. I use Rundeck to launch it manually over SSH. That's been my rig for 10 years. And it's not straightforward JMeter. It's like JMeter plus Mark's special sauce. And that doesn't if you try to shift Mark's special sauce to the left in the pipeline, that doesn't work, because they're like, we have to be Mark in order to make this work. And that's not going to happen. So this move to K6 was it's programmatic. It's a tool that web programmers in particular with JavaScript, could adopt more easily. Like you would with Neoload. If you're going to work within the Neoload functions, you can program a script. I would say somewhat like LoadRunner in an ANSI C world or the C# world, that kind of stuff. But like everybody knows, that JMeter JMX file was just murder. You would never push that left very well. So the move to K6, plus then also kind of trying to keep a K6, our strategy really simple, so that you could just launch kube control, run K6, there's your script, have a nice day, and just have it work without all sorts of super command lines or anything like that.
I'm curious because K6 has a K6 operator for Kubernetes, and I tried it out. So it provides an extra CRD. And this CRD is basically, you put your script and your reference of your, and then it will be scheduled. And you can do also generate load on different containers in the cluster. So it provides a couple of more options than the traditional container approach from K6. I mean, the vanilla one, I would say. So have you tried it?
No, I have to look it up. And it's a little bit new to me. A lot of the rig I use, we still have Rundeck, because we have stuff that's on the pipeline in TeamCity, but then we have just scheduled runs that run every day at 4 in.the morning, every day at 1:30 in the afternoon, that kind of stuff. So we still have stuff sort of pipeline adjacent, firing off scheduled runs that you could push whatever build when you're going to push it, but our load tests don't fire off. We're not shifted left. We kind of come post deployment. Moving forward, we should look at that. And figuring out, after our CD tool pushes stuff into QA or pushes stuff into UAT, what are the tests that we line up right after that? Which would bring me to my first experience of this, which is if you're used to manually launching a load tool, if you're used to then figuring out how to do an unattended launch of that, or a scheduled one, or if you're running in the cloud and there's a whole bunch of infrastructure, but I upload a script and it just runs, you have to get used to the idea that you're not holding on to the steering wheel of your load test. These are you're not in like actually driving the thing. You're setting up the unattended automated stuff, and then learning how that actually gets launched and how it gets sent. That's kind of a new. So I'm going to check out the operator and learn how to make that work. For us, we'll probably have the CD tool then call that directly. I will tell you also, the rest of my company is only 2 other areas are like really building apps on top of a Kubernetes mesh, or on top of the clusters. And then we adopted it just because I was like, look, this learning is going to be good for us and everyone else around us. So even our systems under test that we're pushing load to are not running in Kubernetes. They're still running on VMware or running in Azure.
So there's an interesting experience that I had, which in fact, through that experience, I learned an issue. And it seems that by looking on the internet, by Googling it, other companies had faced the same issue that I had on my cluster. So I was using K6, and I wanted to do chaos engineering and load testing. So I scheduled those different experiments. The way I was scheduling the load test was not through workflow. Was I used cron jobs.
Right.
So you can create cron jobs. And in that particular cluster, I implemented a mesh, a service mesh.
Yep.
So as you know, so the service mesh comes with a control plane and data plane. So the data plane would be basically the service mesh will inject in every workload that, of course, has specific annotations. They will have an extra container in their pod, and that container will be there to do any proxy, so a proxy work,
right.
to do the communication between services, apply some different specific routes that you may define, and so on. And the funny story is that I have defined all the routes and everything. And when it comes to cron jobs, so a cron job in Kubernetes, you have a job. So you have a container that runs. So you have a load test for 50 minutes.
Yep.
And then when it ends, the container ends, it dies, and the jobs stop. And then what happens is the pod is being is terminated, and then memory is released, and so on. But if you add a sidecar container in that cron job, so the job ends, so your load test, but the proxy, it never ends.
Oh, so it doesn't ever let it. The pod never deallocates.
So I launched it on a Friday. And then Monday morning, I connected to my cluster. First of all, my cluster was not responding. I say, what happens? So then I said, what's something wrong here? So then I started to troubleshoot, and I looked at the namespace where all those load tests was running. And then I was seeing, I don't know, there was I think there was like 500 pods. And every pod, of course, were allocating a significant amount of memory. So at the end, I killed my nodes. Just by having this situation, so which means
that little routing proxy pod just got left over. Because the cron job was running the load tests all over and over again throughout the weekend, and then just leaving these little guys hanging out there.
Yep. But the problem is that when you have a pod, the pod allocate the memory that you've defined. So the memory in your node is never released. So then your node is consuming until there is nothing left in the cluster. So it was an interesting experience. And it seems that true story, I looked at the failure stories on Kubernetes. There are major e-commerce brands of the internet that has the similar issue with mesh as well. So, but in their case, it was not a load test; it was a analytics batch. So they were running batches, but the mesh, because of the mesh never ends. Kubernetes waits that the pod, the container ends, and in this particular situation, that's true. There is no pods finishing.
Who was? It was Steve that was with us from Meshery, the last AMA. We've looked in that. HashiCorp is another one that does a service mesh. I think it's called service mesh or Meshify, something. There's Meshery, service mesh. You can also just roll your own in an Nginx way, right?
Yeah, of course. I mean, Nginx, no, but there is Istio. Istio has, of course, the most popular open source solution for service mesh. But the other one, which is very, very, I would say it doesn't cover as much protocol as Istio, because Istio rely on the proxy called Envoy. Envoy is very advanced. Provide a lot of features. But if you just run HTTP and gRPC and you don't need fancy protocols, then Linkerd, which I tried out recently, it's very simple. I mean, it makes your life easier, because Istio is great, but when you start doing a lot of network policies and stuff, then you need to know very well what you're doing. What you're doing,
Yeah.
otherwise you can have surprises for sure.
Yeah. Very cool. So there's a bunch of other, oh, by the way, who's with us? Snacks Testing. Thanks for joining us. Greetings to you as well. If you have any, Henrik is the host, so he's in control of the questions and answers and things like that. So
Surprisingly, I don't see the questions so far, and the UI is not loading the questions.
it's not
So
a question. It just says greetings. So shout out. That's very cool. There are some lessons learned that you and I started chatting about if you're going to run load on this cluster. Oh, it's Eric. So we don't Eric. Eric has a last name. It could be Eric. It could be Eric Pregler. Could be who knows. Snacks Testing on Twitch. So welcome. It's Eric Martin. Eric Martin is one of my colleagues. He's now known as Snacks Testing. Thanks, Eric. Welcome. So if you have questions for Henrik, Eric's an awesome automation person at my company. So cool. So Henrik, you and I were throwing around a bunch of best practices. Like I'm running a physical 4-node cluster. And of course, I can put multiple workers and I can put pods. I get my nodes running and that kind of stuff. But there's one of the ones right off the top that's like, oh yeah, if you have the system under test running in the same cluster, maybe not in the same namespace, but on the same physical machines, that's that same age-old thing. You don't run the load script on the system under test. So in your experience, and you would know more of this, I'm just learning this, in Kubernetes language, how do you manage that? Is it separate namespaces, separate physical pods, assigning worker nodes? How do you actually govern that as a best practice?
More about nodes, because
Nodes.
at the end, I want to make sure that I have dedicated nodes for my apps that I'm going to test, and then of course, if I apply stress, if I have my load testing running on the same node, I will of course generate more CPU due to the fact that I'm generating load. So then the way my node has been utilized has been strange compared to a normal situation. Same thing for observability. So if I start running load and then have my observability stack on top of that, and suddenly I am putting too much pressure and also impacting my observability solution, then I have no way of understanding what's going on. So my first recommendation is to try to split your cluster by having dedicated nodes for your apps, dedicated nodes for observability, dedicated nodes for load testing, load generation.
Load gen,
and for this, there's plenty of different way of getting Kubernetes. You can do it with doing taints and tolerance. You can do simply doing some label selector. So you take your nodes, you apply some labels on it. So this one is going to be an observability node. This one is going to be a load generator node. This one is going to be a worker, or a pure worker node. And then when you do your deployment, you will precise by annotations that this is going to be a workload of that type. And when Kubernetes is going to be basically orchestrating it, it will basically put the pods on the right nodes to avoid having the stack impacting the applications or the observability. So that will be my first recommendation.
Yeah, and again, label selectors. What was the one before that? You were saying
you can basically you can do taints and tolerance. It's the same thing. So you can say that I have you can make some taints on the nodes, and then when you apply pods, you apply also the same stuff. So then when it's the same thing as label selectors, but taints and tolerance, you can have a tolerance, notional tolerance, where it's if there is no nodes available with that taints, then there's so you can have a toleration policy as well.
Okay. Yeah. So you don't overload your loading.
Or your load doesn't overload the stuff that you need. Or
that you load,
Or you measure properly your stuff, at least.
Yeah. The second one, so that's really good, especially if you're new to Kubernetes in any way, shape, or form. We'll get to elasticity in a bit because we talk a lot about that, but I have a couple specific things. Another thing that strikes me is, a lot of if you're doing performance engineering more towards the infrastructure side and maybe not towards finding code anomalies or code optimization kinds of anti-patterns code wise or configuration wise, if you're being asked to size a system. Let's say, hey, what should it be our initial set of replicas? What should our thresholds be? And some of these things in terms of scale and sizing. If you're doing that testing and everything is munged together, it's much harder to say exactly this number of CPUs of this spec, exactly like the old configuration of your server and how many you need fades away because, again, from the modern web way of doing things, you're like, look, we're going to set up the system that if you need CPU, you can just elastically get more CPU. So one of the mindset things I think that changes is, hey, how many transactions per second can we get on this definition of a single server? That initiative, like strategically as a work item, like for me as a worker to go figure that out and get an answer, that's kind of fading. To me, that's a little bit obsolete. Like it doesn't quite apply to this new infrastructure, a more elastic or a clustered infrastructure like this. What are your thoughts on that?
Completely. Yeah, completely. Because the first thing that when you're running in Kubernetes, even if you don't have any notion of cluster that auto scales with more nodes,
Yeah.
You have this CPU throttling that could, because in a control environment, you don't have necessarily some throttling. And here, because the fully containerized environment and you're sharing resources, then whatever you setting, whatever the quality of the code that you deploy, if it's very awesome, but then you do the wrong deployment configurations, then you can have the worst experience on the application because of this throttling that happens. And also the throttling is very complicated. And the notion of throttling is related to heritage of container environments. So containers, the way they share resources within a physical machine, it uses C groups and CFS. So it's a way of orchestrating, so sharing CPU resources. And in fact, it's more about how much time do I have within a CPU cycle. So I have one core, have one CPU cycle of 100 milliseconds. So you have two cores, then I have two CPU cycles of, and so on and so forth. But when I define my limits, those limits are not expressed in core, they will be expressed at the end in function timing. So if I set a 1024 millicores, that means a full core, and a full core means I have 100 milliseconds. So so I have have an application running without threads. So I set the limits of 100 milliseconds. So then that means that I'm able to consume 100 milliseconds of my program. So if I have one single thread app, then I'm consuming 100 milliseconds and no impact. Now we made a revolution. We say, hey, now we're going to make multi-thread. So now my app, instead of having one thread running during 100 milliseconds, I have maybe 10 threads running. So now instead of having a one task for 100 milliseconds, I have 10 tasks running. So I don't have the same amount of time anymore. So I have basically 100 milliseconds divided by 10 to run my program. And when I spend that time, so I will just run for 10 milliseconds. And after 10 milliseconds, each threads will be paused until the next CPU cycle. So if I have 100 milliseconds, I have 10 threads running. So they run their task. And then for the rest of the cycle, they will be paused. And then Docker, Kubernetes, will restart my threads again. So, and this behavior is just throttle. And this is just so much impacting our systems because, imagine you try to do something, I don't know, you work in an environment and it's only, and then, so you continue posing yourself.
And so is there a name for that in terms of like container runtime pauses or blocking of some kind?
It's just CPU throttle. So in any case, there will be some throttling. So don't be too extreme when you see throttling. But for the moment, the throttling starts to reach a certain level of time. then yes, then this is going to be a problem. So you
Yeah.
can have a very low throttle; it doesn't going to impact you. But if you have to start to have a, let's say 25 or milliseconds of throttlings, then here you can say, okay, so I'm running into
Yep.
issues. So
Yeah.
here,
And it should correlate to watching the CPU on the machine reaches a certain point where you have no cycles. Like I have no more cycles free to give you
in fact, you don't see
across
it.
that.
The problem
Yeah.
with Kubernetes is you don't see it because basically when you deploy, you put your request and your limits. So at the end, Kubernetes is saying, okay, so I'm going to allocate those, and this is going to be for you. But then even if you allocate, then you have different programs running, and then they're sharing the cores, and you don't necessarily have an impact on the CPU usage. It's just
Yeah.
that it's the way it's tried to say, oh, you okay, so have child number one, child number two, child number three. So okay, so start doing your your task, child number one, and then now it's time for the child number two because we need to be
Yep.
equal to all the childs. But yeah, that's a consequence of containers.
Yeah. So replace the old goals of what's our sizing for scalability, number of servers, physical configuration, that kind of stuff, with how do we tune the container runtime so that it has the least amount of pauses to basically to avoid throttling, to avoid CPU throttling
Completely,
within the
completely.
cluster.
So
Yeah.
I think running a test in a very minimalistic container environment will make the job to figure out how much core do I need, how much
Yeah.
memory do I need to run my program or to do most of my task, and then what will be the limit, the max that will be authorized,
Right.
and you
Right.
need to make that work by defining those numbers, and then once you deploy, you will use those numbers, and normally, if everything goes well, you should not be impacted if you did the right job. But
Yeah.
that's the first task is
And
defining
and
the sizing of your deployments.
yeah, and make it and it makes sense now why you would want your load generators to be separate from the tools or the application under test or the different container pieces, because you don't you don't want throttling back here to affect throttling over here. You don't want your load tool to be throttled while you're putting pressure. You want the system under test to suffer, right? Like you want, like the whole goal is like we want the tool to be nice and clean so that the system under test reaches an actual limit of some kind, and then you learn how to configure the system under test and you throw your load tool away. Well, maybe not forever, but until the next release. Gary's here. Hey, Gary, long time no see. How are you, man? He says all your memory is mine, I think is what he means to say. Isn't that all your base are mine? Yes. Hi, my name is Kubernetes. Can I have another dim, please? I'll have some dim, please. Give me more dims. I like dims.
So but the memory is another story because the memory,
Okay.
if you consume too much, Kubernetes will kill you because you could consume too much. But I think
Yeah.
the other aspect that you brought up was number of replicas. So I think you need to size how much work can I do with one single instance, and
Yeah.
then if I need to do that amount of throughput, how many minimal replica do I need to at least take the normal load of my traffic or my system, whatever, and then from there you can start to say, why let's do HPA, and
Yeah.
then here starts the problems. And the
Yeah.
HPA is a wonderful technology, but uh, I would first of all never configure HPA based on the traditional metrics provided by Kubernetes, which is CPU and memory.
Yep.
As performance engineers, you cannot only limit a decision based on CPU and memory. It doesn't make sense.
Yeah. Yeah.
So for this, that's why you need to have update your environment to have more metrics exposed to use HPA. So for those who's not knows what is HPA, HPA
Yeah.
stands for horizontal pod autoscalers. So basically, you define what is the minimum replica do I need, and what is the maximum, and then Kubernetes will scale up to the
Yeah.
maximum that you define, and scale down if based on the thresholds that you define. So if you just define on
Right.
CPU, then you will make the decision by on CPU usage or memory usage.
Right. So to me, that I do have an age-old rule of thumb that's always I call it the 1x, and a 1x load means no one's going to get fired, and customers will be pretty much happy. If customers are happy, you're probably not going to get fired. So tuning to figure out from one particular pod how many pods you need or how many replicas you need to handle the 1x, no one's going to get fired kind of load is good. And then you would do tests to estimate 2x, 3x, what are our spike loads, that kind of stuff. But how do you survive the day? And do we have enough hardware? Cloud-based may be nice, but if you're running this on a local, physical, limited cluster, yeah, you'll need to figure out what the max replica is. And then, of course, that's the classic performance issue of, hey, as long as everything's running great, we will have this much memory. But it's the unexpected, oops, something went wrong, and suddenly things back up, the latch time goes up, and your heap size goes through the roof, and you're blowing out replicas like crazy. That's a classic performance anomaly. Like, are you doing your negative or chaos testing to that point? High latency, lost connections, repeat connections, clogged connection pools, and things like that. Very interesting. The one thing I wanted to say, talking about HPA, is also talking back again to those load testing tools. If you're transitioning to this world like I am from a JMeter world, in JMeter they have that sort of parent-child or the clone. So you can run another. It uses RPC communication. Like, here's another instance of JMeter, and it sort of it's like. And I always hated that because it basically says, here's a copy of the script and you run over there. And it's like, well, wait a minute. Like, I
What
have
about the data
thread.
set?
Well, data sets, do I split the data set in half? What if I have unique data? And what if I'm I'm judicious about using my machine name, thread number, thread group. Like, I use those in unique data parameterization and things to be like, there's only one virtual user thread number 243. And so if I have data that has 243 in it, there'll be no other data. It's totally unique data because that's the only, well, now I have another instance of JMeter with a thread 243. So now I have to think about partitioning my load engines across different instances. Well, if you're using a load tool that can be elastic across multiple replicas on your cluster, and it will, hey, we need more load, different load tools, and I'm learning that K6 does a good job of this, you still have to think about your test data and how you segment where you get that test data. And the old school, for me, I like putting test data in a CSV, ready to go, no CPU, no crunching, no nothing, and just suck that in memory and throw it down. Well, now there's new techniques for how you get unique test data into that virtual user, into that load generator to use. You could pull stuff off of like a little Python flat web server. So you just pull it on the fly and serve it up in JSON format. So it's like consumable by the script and away it goes. So there's lots of different techniques to do that you need to think, how do I get my test data? And if I have to grow test data and then consume test data for each cycle of the test because of test data setup, where does that test data live? Do I have persistent storage in the cluster? Or do I put it somewhere and then download it into the container and then the container can use it? So there's all sorts of considerations about that running multiple instances of the load tool or the load generation tool that we kind of took care of back in NeoLoad and Load Runner. Like, we figured out, here's a CSV file and it'll split it up and do its thing.
But
now you kind of have to do that yourself.
Yeah, or you can just map a shared volume between the same containers, and
Yeah.
the data set will be shared. But that's true. And I thought that NeoLoad did when they introduced the data set, they did a pretty good job. But the only thing is that every load generator, when you have a unique data, it's the controller who makes the decision who is going to pick the data. So which means at the end, at the beginning of the tests, the controller depends on how you define your data sets. It's the controller who's sharing the data set properly, equally to each machines, to then they can run the test. Or you can have the other thing where you have unique, and then it means that the load generator says, "Hey, controller, give me the next chunks of
Unique
data
rows.
set. Yeah. So that's good. But if you have, I don't know, let's say a test involving 500 load generators, then suddenly each load generators needs to do some connection to the controller. So then that introduce also constraints to the controller's
Yeah.
level.
So options that we're exploring for that are just a simple static file server. Like if Python can do it, Nginx can do it. Just serve it, and you can treat it sort of. You can just hit the file system and surf the file system and pull the contents of a file in raw format. And if that raw format is JSON, Bob's your uncle. If that works well, I was looking. We're also my buddy Cliff's a Python nerd. For all the Python nerds out there, I was an old Perl nerd. So a Perl. Did I say Perl nude? I was a Perl nude. I was a not safe for work anymore. No, so Python nerds. So Locust, I guess, is also has some great like over the last n number of years, elastic load generators, similar things like using Python pulling a data set down off of a web. The other weird thing about that is in the load tool where you're making web requests to the system under test, you might also then be making web requests
To
to
the
go
other.
get test data and pull it in and use it in a request. So factor that into how you're thinking about, well, what's the total traffic in and out of a given load generator? Because it's not just local CSVs at that point, the way you're doing that. The other, and then, if you're in the Linux world, get familiar with the split function and sort unique. So you could actually split a file up and just say, I have a huge file with 100,000 rows. I split them into 1,000 different files and let it go, depending on how many threads. The other thing is these other tools. So you think about the Go infrastructure behind K6. We're learning a lot about the non-blocking I/O. This is the same thing in Node or Python, the way Locust works. So you don't have threads or virtual user threads the way the traditional load tools that I have known and loved for years. So you're thinking a little bit different. Like I can't say this thread equals this file anymore. It's more like, I need to get unique data on the fly in a slightly different way. So especially if you're operating in the cloud and you're even further removed from potentially the volumes or the physical nature of that cluster, this is all very logical stuff that's in your brain might seem like it's all just flying around and then it disappears, which is a whole other part of the pods being ephemeral. To your point about the proxy pod that's hanging on and hanging around and consuming memory, that's another part about results. And maybe you could talk a bit about the K6 output extension that you were working on for Dynatrace, one for these other tools. Running the load, and then with JMeter, I would write everything to a JTL file, or I would load runner, neoload, like here's my physical files. I ran the script here, and right on the / folder, whatever, right there is all my raw results. After the test, where do I put my raw results? And now we're throwing them across the wire into a time series database, into an observability tool of some kind. What are your thoughts on that, Henrik, as you've dove in with this in Dynatrace so far?
I think because of the evolution of the architecture we're designing, the load test as we speak 10 years ago is different from the load test of today.
Yeah.
And every load testing vendors a couple of years ago, they had to, I need to have a feature to build scripts. I need a feature to observe the environment, because traditional monitoring solution, they don't have the same ability to collect as much metrics as a load testing needs. So we were also building our own monitoring stack for load testing vendor solutions, and then they will also have the analysis solution where you can put your statistics compared to the infrastructure metrics and so on. And I think now, if you look around, the observability has taken over. The notion of monitoring is completely different.
Yeah.
We obviously, as a performance engineers, even if we didn't have the notion of observability a couple of years back, but we still had to look at files, at logs at a certain stage. We had to look at profiling as well sometimes when everything was slow, and that was a bit. We were in fact a bit like the pioneers of the observability world.
Yeah.
at that time. And I think now, because we have already platforms that are able to consume and ingest all the data, index that, and have everything in the same in a one single pane of glass, which is great. I think
Hmm.
why do I need to put everything on the load testing solution, where
Right.
on the other side I have all the details that I need? Maybe
Yeah.
it makes sense to use load testing for generating load, and then
Yeah.
use solution that has the data and that helps you to correlate and understand what's going on in that on those solutions. So I think a solution with Prometheus Grafana is great, or if InfluxDB and Grafana is great, or Dynatrace, of course, is awesome. So I
Yep.
think if you need to take a decision and collect and make a decision based on different metrics and indicators on different level of the architecture, I think Observability will have more options for you to analyze that. And again, keep
Yeah.
in mind that ingesting all that, I remember uh, I was doing huge load tests a couple of years back from the cloud, and then you get this huge results, and then you start to analyzing it. The results, just the results file is a couple of gigs, and then you try to analyze it locally, and it's just a nightmare because you need a lot of memory to do that. I think, yeah, now we
Yeah.
need servers to do that for sure.
Yeah. And I think that also the questions are different. Like, I think the basics of, um, there's no other way to know the hits per second. And the nice thing with observability tools now, from a tracing and logging in particular, not just the monitoring or profiling part, but tracing and logging, you're looking at, for the most part, for real-time load testing or load, let's say analyzing something in the last 24 hours in any of the major tools, you're looking at non-aggregated trace and log data, which you could run all the calculations with the indexing, even the default indexing. Datadog's default indexing, great for tracing. Dynatrace's indexing, the way it pulls in metrics and even doing request attributes like you would pull in from the logging or from the test tools on the headers, you can infer the same major graphs to look at the health of my load and put the observability tool monitoring underneath your load generators, which is a best practice that we used to do with the load tools for years. Do that even though you're running your load on a Kubernetes cluster, so you could see, oh, you're overloading your pod, or oh, you're pushing into CPU throttling land, consuming too much, and you could even indicate thresholds that say, I'm pushing too much load on this cluster, and now I can't trust these results, which is a very important thing to do. Even, let's say you've got bad weather in the cloud. I love that phrase. Like Azure recently, right? So let's say you're using persistent volumes and things, and suddenly the Ultra SSD clusters are completely whacked in your availability area. Uh, yeah, so suddenly you're like, oh, you could even correlate alerts from your Azure tenant into saying whether this load test is trustworthy or not, the level of confidence. And that's something when you're in an isolated lab on the present, like you're like, of course I trust it. You're going to trust me building this test harness. Well, now we're running in these ephemeral waves that spin up, spin down. Um, we haven't talked about Terraform, but I think the new world for me was I could actually pull less data from the raw results into my observability tool and get the same useful, helpful graphs to see a load test in real time. Just like you when you didn't have something, you're like, oh my God, this is great. I have all this stuff. And then once we built these great tools, NeoLoad, I give you super props for that, Henrik. These fantastic tools, you're like, well, now that I have it all, I really use about 4 graphs to drive all of my conversation. Sure, I love all of the other details that we could get from profiling, but I found myself really load wise. It's like 4. How many virtual? What was the load profile? What was the mix of traffic? How many transactions were I sending in? What was the response time? Like, there's like 4 main chunks of info that are the starter of the conversation. And if I'm running in the Kubernetes world, and I don't necessarily have all of those same metrics and everything coming back to my load tool, we gotta find a corollary to do that. That's why I like the K6 extension that you're doing. We've done it sort of with the JMeter best practices, sending stuff on the headers. I think there's a Dynatrace JMeter backend listener that
There's yeah.
Justin does. I'm not a big fan of the backend listeners. I kind of like to get data out of my load driver as fast as possible and free it up to do whatever it's going to do, instead of using resources in that runtime to do other stuff. So I'm a fan of spitting the exhaust out and then letting some other tool pick it up, because I don't care if it shows up in Dynatrace in a minute or two, that's fine. I don't need it in real time. Same kind of thing.
Yeah, and then you have all
yeah.
the, and also I remember a few years back, Stain Shepherd's saying that we need raw data, and because we need to make decisions, which is completely true. And I think he at that time, I remember he said, I don't need a load test doing fancy stuff. I just need a load test generating load, and for the rest, I just need the metrics and the raw data, so then I can do the cross analysis between all the data that comes out of a test. And I think that's what we need today, because our environment are so complex, especially if you do load test involving different data center, different many different applications. Then it's a mess to analyze everything, and having something that at least give you or help you to point out, hey, maybe you should check there. At least you're saving tons of times. I think that's
you and I both worked in the business of load testing tools from the NeoLoad perspective, from an HP or load runner perspective, and we've been supporters of many of our colleagues and friends building these tools. They're at an inflection point as well, for the last 5+ years, 5 to 10 years, reinventing themselves and teeing up. So it's like, how do we run in the modern web infrastructure? And I think I came right into it, even with JMeter, or even if I were in the load runner world. It's when you think about, what do I have to do to shift this discipline to the left and run in this new infrastructure? If you've ever needed a chance to take a deep breath and maybe rebuild your scripts and start collaborating differently with your developer and tester engineers, automating differently, leveraging the alerting in your platforms, your observability platforms, and development and test, if you can use, it's enough to say, all right, I'm not saying you should throw away your load testing tool, because there's fantastic innovations there, but it is an opportunity to revisit, hey, we're going to have to go through a little bit of a refactoring hump to get this to work really smoothly. It's like, for me, sure, I could run a JMeter container, but I could only run one replica of that script. It's the same thing I'm doing locally on a machine right here. I could run that on Kubernetes and woohoo, I'm done. But I'm not really taking advantage of everything there is to offer in some elasticity, in multiple replicas, in running portability. I get a little bit of that. Plus, I haven't learned a new tool. And I'm still in a tool that doesn't shift left very well. So I would encourage people, don't be afraid, just like I am, after 30 years of playing around with load testing tools, let's go learn a new tool. I'm learning 2 new tools. So it's a good thing to constantly revisit these and call your existing vendor and say, what aren't we doing with your latest features? What else do you have for me?
And I think also another point is, if you're still testing from the UI, which makes sense, and I don't say that you should stop doing this, because at certain stage you will still need to test from the UI. Yeah. But again, if you want to be identifying problems as early as possible, you should try to reconsider your approach of testing. Because keep in mind that that defects, if you detect them very late on the cycle, they will be more expensive to resolve it. So that's why let's change your mindset and try to make simple tests, small tests that will cover specific aspects, specific risks of your systems, and then you will move step by step and add more complexity to your test. And I think sometimes with a very fancy load testing solution where you have lots of options, lots of protocols, it's great. But again, do I really need it to fulfill all my requirements?
Yeah. I think that's good. Yeah, I think it's also some people just naturally a fear of change. You get so far and doing the same thing, it works, it's successful, and you might find that the problems you're finding and the questions you're asking maybe have aged with you. And if you've got a lead team, an architecture team, a forward-looking strategic architecture team, there's like, we're going to build version 2, version 3 of the platform, some new cool stuff. We're going to start running here. Don't shy away from it. Say, hey, you know what? We might need some slightly different tools to do this right. And don't shy away from it. I always like encouraging people, if you can learn something new and do something new, even if you fail miserably, just make sure you tell people there's a chance we're going to fail miserably. There's a chance, but at least that's part of pushing the envelope for what you're doing, and it's worth doing. And you've got great resources. Like, I know the K6, when you jumped over to Dynatrace, you're like, all right, I'm going to go do some stuff with this. Great. It was awesome. There's helpful people that have been doing this a while that are contributing stuff. So yeah.
And I think last point, because I'm looking at the time.
Yeah.
I think with the standard open telemetry being more mature, and the adoption is growing, we should have more and more testing solution. First of all, producing, so starting the traces from their end. So then you have the ability to track each of your users and understand and be more efficient when you analyze. So
Yeah.
follow what's going on OpenTelemetry. And I think the testing walls should be already you taking advantage of that. There's a great solution I've just tried out. I'm going to release soon an episode on that, on Is It Observable, on trace test. The trace test is an open source solution. The way they build it, you fire an Postman collection or HTTP or gRPC, and it connects to a observability solution. So it fires a test, some traffic, and it will basically start to trace. And then it will reach out to the observability solution, say, hey, give me the trace of this ID, because I am the one that has started it. And then it provides the full trace on the screen, and then you say, okay, I want to do a functional test, but I'm going to do some selector on specific spans. So I want to control that, first of all, the front-end layer is responding with the right content. But I also want to double check that I have 2 spans from the get product function. And then I have 3 spans on this one. And I have the spans on the payment system needs to be under 200 milliseconds. So basically, you don't do a basic just I send a request, I get a response, and you control just the content or the HTTP code. You're basically controlling what's going underneath and the architecture based on the traces. And I see lots of value of that, which means you can even use it in synthetic monitoring, where you check that your service is responding, but you can also check that your service is responding, and all the underlying services that are called by your web server, they are also responding in time. And I think this is great. And I think that will change the testing market.
The span and its traces become expected results.
Yeah.
You know? And secondarily, then there's compliance. What percentage are we with compliance or adherence to these spans and these traces should always operate like this? And suddenly someone puts in some code, and we're now branching over there, and we've got some other new span that got connected. And whoa, who wrote that? Oh, well, so and so from this ticket was approved of the thing. And it's like, okay, change control, all that kind of stuff, governance. I know a lot of people shy away from the big G, governance. But thank you, Gary. Nice to see you, man. I haven't seen him in years. I hope he's doing really well. So yeah, I think that's cool. So what was it? Tracer test?
Trace test. So tracetest.io, check it out. Tracetest.io. I would definitely. So it's very basic at the moment. They're going to add more and more features on top. So it's open source solution. And from what I see, now you have just a minimal component, so you can already see the value. But I think if the community contribute to that project, wow, I see lots of potentials behind the scene.
Oh, that's a cool idea. All right. I know Eric will check that out. That'd be pretty cool. Henrik, it's great to see you as always. We're going to do this more frequently. Henrik and I and Leandro are going to figure out a regular schedule for this and maybe run some topics in a backlog. But I'll say like you just said, you have stuff still on Is It Observable?
Sure.
And that's where a lot of the news. So if you haven't been over to Is It Observable, we usually have links and things we pop up.
Yeah, I can
But
pop
we'll
it up.
put them. We'll put them. I don't know if you've got it. It's Is It Observable on YouTube channel. Is It Observable? And it's a question. It's not a statement. That would be it is observable. This is it observable? It's like Will It Float from
Or
the
will
old
it blend?
David Letterman show.
Or will it blend? No, does it blend?
Does it blend? I usually on Fridays I do my YouTube thing. There's still Perf Bites Espanol are over in the Perf tour. Scott Moore's doing the Perf tour, and you'll see Scott's going to go to the Neotis Pack. We also have our friends at Abstracta. We've mentioned the Whopper or performance-workshop.org. It's Whopper 29 in Uruguay in Montevideo.
Yep. Let me show this one. So this is
It's on the
announcement.
ticker.
So there's the CFP is still on the way. So if you want to participate to a brainstorming session on performance and reliability this year, Abstract organizing in Montevideo. So check it out and submit your CFPs.
And there's not just the Whopper. I think there's another sort of one-day conference or conference happening as well, which would be Abstract and Performance. And there's those guys are super smart dudes. So it's going to be a good time, and it's about time we got back together as the Whopper world. So check that out. And as usual, Henrik, it's great to talk with you as always.
Yeah, me too.
It
was great.
Yeah.
All right. So I think we are top of the hour. So Mark, I will have a great end of the day and see you soon for another Ask Me Anything or another episode of Perf Bites.
Exactly. Ciao. Adieu.
Au revoir.
Ciao. Au revoir.